is a short video demonstration on simplifying radicals with different indices. First of all, we have to address, what does indices mean? The word index is one of those strange words in the English language. The plural of index is indices. All right? So when we use the word indices, we're only talking about the plural of the word index. Well, what is index? When we're talking about the square root, of a number, we use the radical symbol. All right, that's a radical. If we want the cube root, we make a radical symbol like this, and we have a little 3 right there. Just like an exponent, it's really small. We don't write it like this. We make it a little number, okay? So, if I had the 4th root, my index would be a 4. All right? So, for instance, what is the cube root of 8? It equals 2. Why? Because 2 times 2 times 2, 3 times, is equal to 8. Now, we know that we can't do the square root of a negative number, but we could do the cube root of negative 8 is negative 2. Why? Why would the cube root of negative 8 be a negative 2? Why? Because negative 2 times negative 2 times negative 2, negative times negative is positive, times a negative is equal to negative 8. So when we're looking at cube roots, fifth roots, whatever, you can have negatives. If this number is odd, we can take the root of a negative number. All right, let's look at a few quick examples. First of all, the cube root of 81. Just like before, we're going to break 81 up using prime numbers. 3 and 27. 3 goes in there 9. 3 goes in here 3 times. However you do this, whatever system that you used. I like doing it this way. Some of you do it slightly different. It doesn't matter. Now, instead of looking for pairs, it's the cube root, we're looking for 3. So I have 3, I pull the 3 out. Instead of looking for pairs and then writing a 3, I look for 3 of a kind. And what's left goes inside the radical. You must have the index here, the cube root of 3. Without that index, it's wrong. Very common mistake. All right, 4th root of 16. So 16, 2 goes into there 8, 2 goes into there 4, 2 goes into there 2. Now I'm looking for a group of 4. 1, 2, 3, 4. So it's equal to 2. And nothing's left inside our radical. All right? It's the same procedure we've been doing. All right? Now let's look at the 5th root. 2 more examples. Scroll down here. The 5th root of 128. negative 128, I'm sorry. Now, I'm going to ignore this negative sign for a minute. So we have 128, 264, 232, 216, 28, 24, 2 and 2. Now, we have 1, 2, 3, 4, 5, 6, 7. So negative 128 is equal to negative 2, in parentheses, raised to the 7th power. All right? So, even though I did these with positive numbers, we're thinking negative numbers. So now, I pull out 1, 2, 3, 4, 5 of them. But remember, these are all negative 2's. Negative, 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 and negative. So when I pull out the 5, it's a negative 2 times the 5th root, don't forget that index, of negative 2 times negative 2. Or negative 2 times the 5th root of negative 2 times negative 2 is positive 4. All right? So the 5th root of negative 128 is negative 2 times this number. And we know that the 5th root has to be negative, and it makes sense to have this be negative right there. All right, last example, 3rd root of 216. All right, so 216, I know, oops, that's not right. It's the 3rd root, all right? Remember, it's an index. Sorry about that. All right, 2 goes in there 108. 2 goes in there 54. 2 goes in there 27. 3 goes in there 3. 9. Let's see, erase that. 3 goes into 27 9 times. 3 goes into 9 3 times. It's the cube root. So I'm looking for groups of 3. I got 3 2's. I got 3 3's. So the cube root of 216 is 2 times 3, or 6. All right? Pretty straightforward, pretty simple. I hope this helps you out, and have a great day.